So we are here with our Inshore Fisheries Independent Monitoring team, and I'm going to go ahead and let them introduce themselves here. If you want to go ahead and we'll go ahead and share that here, and we'll have the team introduce themselves. Thank you.
Hi everyone, my name is Mackenzie Horton. I'm from Fisheries Independent Monitoring at FWRI in St. Pete.
Hi everyone, my name is Brittany Berg. I am here with the Florida Fish and Wildlife Research Institute, also in St. Pete. And here's Brent.
Hey guys, good morning. I'm with the FIM group as well at the Institute. I've been with FIMS for 31 years, so it's just great to have you guys here to talk about what we do today.
All right, thank you everyone for being here. We really appreciate it. Today we're going to learn about the Fisheries Independent Monitoring Inshore Program, or FIM for short, by following a red drum through its life cycle in Tampa Bay. The picture on your screen is actually a picture of Tampa Bay. You can see Tampa on the top part of the picture, and on the left side, St. Pete. Now this whole area is an estuary. It's a body of water that has a mixture of saltwater and freshwater, and the freshwater comes from the rivers that flow out into the bay. Many fish, specifically the red drum, use different parts of the estuary during its lifetime. Each of the fish icons on the picture represents different life stages and where these fish can be found during each life stage. But first, let's start off at FIM's home base, the Fish and Wildlife Research Institute, to get trained before we go out into the field. Now, who are we? Fisheries Independent Monitoring, or FIM, is a long-term fish monitoring program that was established in 1989. What do? We provide timely, accurate, and consistent fisheries independent data and analysis to fisheries managers for the conservation and protection of Florida fishers. And to get all this data, we monitor fish populations of inshore and large invertebrates, look at habitats used by these fish and large invertebrates, look for changes in the populations over a season or year, and collect data to help to determine the life history for age and growth, maturity, and reproductive cycle. And all this information helps us provide data to those fisheries managers to help keep the fish populations healthy. And these fisheries managers are people that use our data to determine things such as fishing seasons, size limits, and catch limits. And so where do we work? FIM has 6 total labs across the state of Florida. Our main lab is located in St. Pete, right outside downtown. And if we have the picture come up, we actually have field labs all across the state of Florida. We have 5 labs outside of Tampa Bay that include Apalachicola, Cedar Key, Charlotte Harbor, Indian River Lagoon, and Jacksonville. And all these field labs actually use the same sampling design. All right, so our sampling design is, in order to understand the stages of a fish's life, we use different types of nets to catch different sized fish. Every fish that is caught is identified, measured, and counted. We also record environmental data, such as location, weather, habitat, and water chemistry. By regularly sampling over a long period of time, this information can be used to make smarter management decisions, which can help protect fish populations and their habitat for future generations. So now you're wondering, how do we catch these fish? We actually have 3 different types of nets. We use one of them twice. So we'll start off with our small net, which is our hull seine, which is our bay seine, which is our 70-foot seine that allows us to catch fish as small as 10 millimeters. You can see that we set it in a bay, or we can do it along a shoreline. However, our river seine is the same net, but we set it along a shoreline. As you can see, we set it along the mangroves. Now to catch the larger fish, we use our hull seine, which is 600 feet long. Now that's about as long as 2 football fields. And then again, that is to catch our larger fish. And for the fish that are in deeper waters that our seines can't reach, we use our 20-foot otter trawl. Now all these fish that come in our nets, we have to ID each of them. So we use physical characteristics such as shape, color of the body, mouth, and tail to identify each fish. For fish that are more difficult to identify, we use microscopes and dichotomous keys back in the lab to identify these smaller fish. Believe it or not, in the picture on the right side of your screen is actually 3 different species of fish. Now it's important that we accurately identify all these fish. That's why we use the keys back in the lab. And each of these fish need to be measured. So we measure using standard length. You can see in the picture at the top part of your screen, we measure from the tip of the snout to the base of the caudal fin or the tail. Now for the larger fish, we will use a length board, but for the smaller fish, we will use a small ruler. Now we'll show you a video on how we measure these fish. So in this video, you can see that we're using the large length board for the larger fish and the small ruler for the smaller fish. And if you saw a close shot of that smaller fish, that we actually use millimeters. We don't use inches. We only use the metric system to measure all of our fish. Well, now that we've got you all trained up for the field, I'm going to turn it over to Brittany to talk to you about the beginning life stages of a red drum.
Hi guys, Brittany here. Let's start over at the mouth of the bay, where larvae come into the bay. Fertilized red drum eggs are about 1 millimeter in diameter and hatch after about 20 to 30 hours, depending on water chemistry. Surface currents from wind and tides transport eggs and larvae into Tampa Bay from nearshore waters. Larval red drum rely on a yolk sac for feeding early on, but develop a mouth and eyes within 3 days of hatching. Our gears typically do not catch these tiny larvae, but we always keep a close eye on our catches, just in case. Next, we move up further into the bay when the fish get a little bit larger, and they're called juveniles. When larval red drum reach 2 weeks old, they begin to change into their larval stage. They move into tidal creeks and rivers to use rocky shores, seawalls, grass flats, and vegetated shorelines to both hide from predators and feed on small invertebrates. Juvenile red drum usually have dark blotches on their backs, which offer excellent camouflage in these areas. We use our 70-foot seine along riverbanks to look for these juvenile red drum as well as other fish. This is an example of a river seine. We begin by dropping one person off along a shoreline with one side of the net. The boat drives away parallel to the shoreline while the rest of the net is deployed off the back of the boat. One person stands ready with a depth pole to take a depth where the bag goes out. The bag is where all the fish will eventually be collected when the net is pulled in. Once the net is fully deployed and the boat reaches the other side of the shoreline, 2 people will jump out of the boat, one with the other side of the net and one person with a bucket to collect the fish in. The poles that are attached to the other side of the net are used to try to scare any fish from out of their hiding places. The crew works together to bring the net in to reach the bag of the net. The person in the middle keeps their hands as low as possible to prevent fish from escaping. Once they reach the bag, the catch is placed into a bucket, brought back to the boat to be counted, measured, and identified before being released. And in areas that are too deep for our small seine, we use a 20-foot otter trawl that we tow behind the boat, but don't worry, we'll discuss that on the next slide. So once the fish get a little bit larger, they become large juveniles and they move a little further out. Some large juvenile red drum will continue to live in the rivers, while others will move into more open waters. They will continue to use protected habitats such as mangroves and seagrasses to hide from predators. We use our 70-foot seine along shorelines as well as shallow areas away from shore. These can be pulled in areas with seagrass and areas without. This time, instead of setting a net along a river shoreline, the net is set in shallow water. The net is stretched 50 feet wide, which is measured using a yellow line in the center. The net is pulled for 30 feet, which is measured by another yellow line that is anchored at the starting point. Once that line is tight, 2 people walk towards each other to close off the bag. Everything that is caught in the bag is placed into a bucket and brought back to the boat to be counted, measured, and identified before being released. We also use something called a trawl. Our 20-foot otter trawl is used in areas that are too deep for seines. They are deployed off the back of the boat while it's being driven at a slow speed. The crew uses their gloved hands to keep tension on the rope to make sure it's set correctly. Each trawl is timed for 10 minutes. However, in rivers, it's only done for 5 minutes. This is because rivers tend to collect a lot more bycatch or debris, such as sticks, leaves, algae, or mud. When the time is up, the boat will come to a stop, and the crew will bring the trawl back into the boat. The catch will be funneled into the bag of the trawl, which is then placed into a larger bin to be counted, measured, and identified before being released. Now I'm going to turn it over to Brent, where he will talk to you about what happens when these fish get a little bit larger while moving further out into the bay.
Thanks, Brittany. Am I live? Yes, I'm live. Yeah. Well, now we're going to talk about that transition from the large juveniles to the adults. Now, these fish can actually use the entire estuary, and they have even a wider variety of habitats that they'll utilize. They still love seagrass beds and vegetated shorelines, mangroves, and marsh grass. Now, we found from our reproductive studies that red drum mature right around 5 years of age, but up to that point, they'll just hang out within the bay and gradually make their way to the mouth before they transition into their adult habitats. Now, you can imagine that, well, these guys, they range in age from about 1 to 4. That's what we catch in these larger nets, and they're about 2 to 2.5 feet in total length during this stage of their life that I'm talking about. Now, we can't catch these larger fish in the smaller nets that Brittany described to you. So we designed a larger gear we call a large haul seine. It's 600 foot long, 2 football fields, if you can imagine. We're going to show you a quick video. Brittany's going to fire that up, and you could see the fin guys in action here. Okay. Now it's set similar to the 70-foot seine in that we let 2 people off because it's a lot harder to pull. We set it in a rectangular shape from the shoreline using the boat. We actually marked the corners with paint, so we try to make it a perfect rectangle. And instead of doing a pole to check the depth, we throw a little buoy like this, and then we go back and check the depth once that happens. All right. So they're now closing off the seine with the boat, and the other 2 scientists on the crew are going to come along the shoreline, and now is when the fun begins. Most people think that scientists are kind of weak nerds, right? Well, not in FIM. You have to be not only smart, but you also have to be tough and strong. Look at Brittany pulling that net, and she's keeping the leads low so the fish won't escape. And these fish, just like the smaller seines, are all being herded, if you will, into the mouth of the net. Notice how they're using their whole body. You can't just use your arms. These nets, especially if the soil is muddy, is very difficult to pull. And these gears are not just designed for red drum. We'll catch hundreds of different species of fish, large juveniles and adults of certain species, bait fish, sharks and stingrays, snook, spotted sea trout. Here you see some smaller bait fish inside the net. Notice that larger mesh allows the little juveniles to get through, but it actually keeps the larger fish that we're actually targeting. There you can see the bag coming in. It's almost done. The guys are gonna, what we call, trip the bag, and then we would kind of work it down. This net has some bycatch in it, which we have to identify and quantify and sort through, and then we finally get to the fish and where we can measure and count those, okay? All right, well, let's make the transition to adulthood now. So red drum has a unique life cycle. When they become adults, they basically leave the bay for the most part. We rarely see them again inside the estuary, all right? So once they mature at age 5, they can get up to almost 40 years of age. They're hanging in our coastal waters, along the beaches, near inlets and ocean passes, all right? And they often school, especially during fall months, is when we see the big spawning aggregations. This picture on the right is a picture of one of those from a spotter plane. These schools will have hundreds, if not sometimes thousands of red drum all in a single school. And of course, in the fall, during when the waters cool down, the days are a little shorter, this is when they're actually they're depositing the eggs and larvae that begin this life cycle again. And the females will release 1 million eggs during these spawning aggregations, each female. So you can imagine how many eggs and larvae are floating around. But it's a very tough gauntlet for these red drum to go from egg to larvae to juveniles in the rivers and then out into the bay where they have to dodge predators and anglers as well. So that's why they have to have so many different eggs. Okay. All right. Well, let's look at, this gives you a good picture as to what we do in FIM. Let's talk about our final research and why it's important. Okay. So what the FIM design has done and developed over all these years is it allows us to monitor not just red drum, but a wide variety of species throughout their life cycle, which is important. We want to know what the juveniles are doing, what the subadults, what the adults. We want to track them at all these different life cycles. And the data that we collect allows us to actually document patterns in abundance, if you will. So how many, are there a lot of red drum in the bay? And if those numbers go up and down from year to year, we also learn about how they grow, when they mature, what kind of habitats they use at different stages of their lives. Finally, that information we hand off to the fisheries managers, and they can plug this into their formulas and consider how they set the regulations for these different species. Okay, is certain species supposed to be prohibited, or can we allow harvest? And then we could set bag limits and size limits that can protect the population, but also allow anglers and people to catch them at the same time. So this is what we do on a daily basis to protect this valuable resource within the bay. But what could you guys do? That's a good question. One way that you can do that, we like to say the phrase of conservation through education. What you guys are doing right now is a great step in the right direction of just learning and talking to scientists of what we do and why we do it, and how that protects the resource out there. But you can educate yourself in a lot of different ways. We've got a great website at myfwc.com that you can learn a lot of different things about, not just fish, but other species. So say you'd like to be a fisherman, like this example here, it's great for you to educate yourself on either the right gears to use, how to handle fish properly, how to catch and release safely so you increase the life of the fish. And then, of course, knowing the regulations, which are updated continually you can either get an app on your phone or go to our website, okay? There's also a great resource linked to the Institute called FYCCN. We like acronyms as scientists. That actually stands for the Florida Youth Conservation Centers Network. And they have amazing outreach programs, summer camps, opportunities for volunteers to not only learn, but also interact with the environment, go kayaking, go fishing, go on hikes, and do beach cleanups, all sorts of great stuff. So the websites are here. Your teachers or your parents can lead you to those. Get plugged in with those different groups. And you can also go to our FWC website with lots of opportunities for outreach during the year. All right. So that's something that you guys could do to start your journey to conserving and protecting fish in the state of Florida. Thanks for your time. And I'm going to turn it over for Q&A to Jonathan.
Excellent. Thanks a lot, Brent.
Yeah,
well,
my pleasure.
Like Brent said, we're going to go ahead and move into the Q&A portion now. So Jen, if you don't mind sharing your screen here, and then it looks like we've had quite a few questions come through already. We had a question from Holly here who asked, how many species that you catch are considered threatened or endangered? Might be kind of a hard one to answer off the cuff, but that was our first question from Holly.
Brent, I'm going to give that one to you. Like, you know most about that one.
Yeah, thank you. Yeah, actually, there's very few fish species in the state of Florida that are threatened or endangered. One of the key ones that we actually do research on for nearly a decade now is the small-tooth sawfish, a very cool fish that was almost wiped out by fishermen and over the years, and now their populations are making a comeback. So we see them mainly in the southern portions of the bay or of the state. Rare in Tampa Bay, but we've caught a few. The center of our activity and research is down in the Charlotte Harbor Lab, where Dr. Greg Palakis, part of our FIM team, actually leads that research team on small-tooth sawfish.
All right, excellent. All right, we have a question from Joseph, who is asking, has anything really unexpected ever happened to you? Maybe in the field, perhaps?
I'll go ahead and take that one. Yeah, there's a ton of unexpected things that happen all the time, actually. We never really know what to expect. A lot of us get stung by stingrays when we're in the field, and jellyfish. I actually got stung by jellyfish yesterday. My coworker got stung by a stingray the day before that. It's quite a dangerous game out there sometimes, so we just have to play it safe as much as we can. We deal with different things like hurricanes and red tide events that we have to change our sampling a little bit, and we have to kind of work around those things. Office closures, for instance, right now with COVID-19, we're all working from home right now and doing this digitally right now, which is unprecedented for MarineQuest. It's really weird that we're not all together in the parking lot of the FWRI having presentations for you guys in person. So we're adapting and overcoming to things like this.
Excellent.
I'm gonna add to that. Is that okay?
Yes, of course.
Yeah. Well, we're fish nerds all the time. So you never know what you're going to catch in a net. Sometimes we'll get a species that, we had never seen in 30 years of the program. So that's always exciting when you get a new species or something outside of its range. But one time we had a TV crew on the boat. We were pulling the trawl like Brittany described earlier, and we pulled it up. Man, this is heavy. I don't know what we have in here. And we pulled the trawl up and opened it up, and there was a toilet inside the trawl. Someone had thrown an entire toilet inside the river, and we caught it in a trawl. Of course, we took it back and put it in the dumpster, but that was unexpected.
Yes, any trash or man-made objects that we come across, that we pull a lot of things like that out of our trawls, but we hold on to all that stuff on the boat, and when we get back to the boat ramp, we toss it away. But yes, we've caught really, really weird things in the trawls, especially. I won't get into that, but weird things.
Excellent. Well, I think we maybe have time for one more question. We had a question from Susan here, and this I think would be a nice question to end on. How would you recommend getting into a career in science and biology?
I take this one. I always highly recommend it. I mean, if it's something you're passionate about, go for it. It's something I always wanted to do as a kid, and I just went for it. I went to school and I made sure I volunteered, and that's the main thing is, volunteering and being, with the community and being with the scientists. That's how I got my job here. I actually was a volunteer first. So it's important to kind of know what you're doing and, try different things, try different, sanctuaries or agencies to kind of figure out what you really like. But I think it's really important, we always need biologists, with our current situation, there's always stuff to learn, always, you can always learn more stuff. So I definitely.
And at FWC too, I'd mentioned we have lots of internships and things of that nature, as Kinsey kind of alluded to there. Excellent. All right. Well, Brent or Brittany, did you have any closing words? No. Okay. Great. Well.
Best fishes. Best fishes.
Excellent. Best fishes to all. Well, thanks a lot for joining us, everyone. Thanks a lot to our Inshore FIM team here, and thanks for joining us. Bye.